Okay, welcome everybody to today's episode of freemathhelp.ca, the grade 9 version. I hope you're all having a wonderful day so far. And I just want to state, like I do every week, that if you have questions that you would like us to answer, please feel free to leave them in the YouTube chat. So I'm just going to give us about 5 seconds for the audio check, and then we will get started. Okay, so this week at freemathhelp.ca, we are doing a bit of a trigonometry theme. And for those of you guys who might not be familiar with what trigonometry is, it's basically the study of shapes and angles and all of that fun stuff. And as the years go on, it does get a little bit more complicated. But for us, we are just going to be focusing on angles today and really just the study of 2D figures, which is essentially shapes. Which are essentially shapes, is what I'm trying to say. So again, like I said, if you have questions, they don't have to do anything with what I'm teaching like we always do. We always teach a lesson just because that way everybody can get value, even if they don't have specific questions. But I'm happy to answer them if you do. Okay, so without further ado, we're going to start talking about 2D figures. And really, like I said, what that means is we're going to be discussing shapes and the angles within shapes and all of that fun stuff. But before we get started on actual shapes, what I want to talk about is something called complementary and supplementary angles. And for those of you who had grade 8 teachers that might have gone over this, that's really awesome. So here I am drawing what one can assume is a 90-degree angle. And we often denote 90-degree angles using a little square, so that's how you know that it's 90 degrees. Okay, and sorry, there we go. And basically what we want to make sure that everyone understands is that there is something called a complementary angle. So I'm just going to use a different color here to kind of illustrate my point. And what a complementary angle is an angle that in addition to another angle adds up to 90 degrees. So I'll do this for example. So let's say we've got that. And this isn't exact, obviously, because I don't have a protractor on the computer right now, but if we were to assume that this angle is 50 and this angle is 40, then both of those angles together, and we'll basically say that this is called A and this is angle B. So basically the rule for complementary angles, and complementary is spelled like this. It's not spelt the way you would say when you compliment someone or if something is complimenting somebody. Okay, so this is a complementary angle. Gosh, say that 5 times fast, eh? And what the rule is that basically when you have two complementary angles, that means that angle A plus angle B is equal to 90 degrees. And for those of you just joining us, I know this isn't that crazy of a concept. It's obviously not too hard to understand, but it is something that you do need to memorize, and it's a really important term that I want you guys all to keep in mind. So that's complementary. That's kind of its own situation. We're just going to put a little bubble around that. Okay. Now, let's discuss something else which is also super important, and we're just gonna, again, change the colors so that we can kind of distinguish everything. And that is what we call a supplementary angle. So remember that a straight line, and if you recall from grade 8, a straight line has 180 degrees from here to here, just like our protractor, right? So this is altogether 180 degrees. And what two angles that are considered to be supplementary are are that what is interesting about them is that they both add up to 180 degrees, and I'll show you what I mean. So let's say I arbitrarily just stuck a line through this and I broke it up and I said that, let's say this side, and let me just erase this little situation here to make it a little bit easier to understand what I'm talking about. So let's say that one side is equal to, like over here, we should say maybe this is equal to, like, I don't know, let's say 60 degrees. And then over here, this side is equal to 120 degrees. So together, if this is angle A and this is angle B, then the rule for a supplementary, which is spelled like this, and I highly recommend just writing these terms down only because it will help you memorize things. Basically, by writing things down, you're increasing the chance that you will memorize it. But the rule here is that these two angles add up to be 180 degrees. And the reason I say it's very important to memorize these rules is because on your tests for this particular topic, typically one of the major things that teachers ask about is the wording and just having whether you have an understanding of what these words mean. And obviously they're going to give you more complicated questions, but my belief in life is that if you understand the fundamentals of a topic, then when it gets more complicated, you'll have a much easier time understanding what it is that they're asking you. So in life in general, I'm a big believer that you have to master the fundamentals in order to understand the more complex parts of a problem. Okay, and let me just make sure that we write angles here as well. Okay. So like I said, this is just kind of a little refresher from grade 8 for most people, but if it's something that your teacher didn't teach you in grade 8, that's okay. Just memorize it. And one way that I like to remember which is that they are alphabetical in terms of size. So complementary comes first because of the C, and that's 90 degrees. And then supplementary is second, and it's 180 degrees. And C comes before S. So that's something that I've used to memorize it over the years, and also has helped my students quite a lot. Alrighty guys, so if everyone is okay with that, and if you do have any questions, feel free to drop them in the chat. But if you don't, we're just going to move along. And even if you have a question pop up later that you wish you had asked earlier, don't feel like it's too late. We have the whole hour. Feel free to refer back. I'm going to keep this page as it is so that we can refer back to it. Alrighty guys, so this obviously gets a little bit more complicated as we go along. There are quite a few rules that we need to understand about triangles and about 2D figures in general. So I really want us to kind of get through as much as we can today, but also at a speed that everyone can understand what's happening. So I'm going to do my best to draw a triangle here, and I probably should use my straight line situation here. So let's say that we have just any kind of triangle, right? And we know from other years of school that a triangle has 3 angles in it, and these angles should add up to 180 degrees. So we'll call this angle A, angle B, angle C, and we know that the rule here is that A plus B plus C equal 180 degrees. That's pretty standard, obviously. But we have another type of triangle, or we have a type of triangle called the isosceles triangle, where we know that the two angles A and B, or in this case B and C, would have to be equal. Okay, and then that's something we can determine based on the equal side lengths of the two. Now, because that's stuff that you guys have done before, what we're really going to focus on today are the more complex rules. Okay, so we're just going to kind of get that going. So let's say we have an angle like, or not an angle, but we have a situation and it looks like this. It's a two straight lines with, let's just grab another color here. So let's say I have 2 straight lines and we're talking about corresponding angles. So What's important to understand is that these lines, oh gosh, I want my pen. These lines have to be parallel. And so when you see little etches like this on each line, usually that means parallel. Okay, now, what's also really important is that we start to recognize the patterns here. So one thing that you can kind of take a look at, I'm going to do this with another color. Let's say pink, just in a nice pink mood today. So I'm going to increase the size of this guy so that we can get a better look. Now, if you look here, this angle situation kind of looks like an F. Okay, obviously my line is not perfect. Oh gosh, I'm gonna try that again. This looks like the letter F. And one of the key parts of this unit is being able to recognize the letters within these patterns. And again, these rules only apply when the two lines that are being intersected by another line are parallel. Otherwise, these rules don't really apply. So let's discuss what the F pattern means. So let's say that this here is angle A. Wow, that's way too much on the pencil size. So let's say that this here is angle A, and this here is angle B, and then on the opposite side, we have this here as angle C, and this as angle D. Alrighty, so keeping all of this in mind, we want to remember that again, this looks like an F, and that these two lines, this line and this line, are parallel to each other, which means that they are completely at the exact same slope, meaning that they will never intersect. And they are being intersected. I mean, they are being, there's a line drawn through them, which is intersecting them, I guess you could say, by this line here. So the rule here is that C is equal to D. So this angle is equal to this angle, and A is equal to B. This angle is equal to this angle. Okay, so what does that tell us in a situation? Well, first I want to show you guys why this is true, because a lot of times I found that that was usually helpful for students, because most of the time in class we don't get a chance to kind of understand why this is true, just because there's a lot to cover, and we've got a little bit of extra time in this platform in general, so I'm going to show you guys. So remember how earlier we were talking about supplementary angles, this right here, supplementary angles. And you see here that 180 degrees is split by this line into 60 and 120. So imagine now that this line kept going and it intersected an identical line to this one over here. So I'll show you guys what I mean. So let's say we had this line and it was down here and it's exactly parallel to the line above. And then this line was just continuing on in that same format, in that same exact slope. So you can imagine, because these two lines are parallel, that the rule of the supplementary angle that was applicable up here would also be applicable, would also be applicable over here. So let me just erase this cloud part so I can show you what I mean. I'll fix that, just give me 1 second. Okay. Pretend that that's like that. So remember, if we had 60 up here and 120 over here, and again, these two lines are perfectly parallel to each other, and this straight line went through both, it cut through both exactly at the same angle, then this is also going to be 60, and this is also going to be 120. So this rule of the supplementary angle comes back into play over here, because again, we see here that we have two angles on either side of a straight line. So obviously, if A was, for example, let's say 70 degrees, and then by way of the fact that this is a perfectly straight line, C would be 110 degrees, equaling 180 altogether, well then it makes sense for this angle, which is on the same exact kind of situation, or in the same exact situation, would also be 70 on this side and 110 on this side. Okay, so I hope that makes sense for you guys. And if you have any questions, feel free to let me know. But realistically, what happens with these kind of questions is that your teacher will give you kind of something that looks like this. And again, it doesn't always have to be exactly like that. You could have you could have two angles that look like this, you know, and as long as the lines are perfectly parallel, which would be indicated by these little slashes, and if your teacher told you just this angle, or just, sorry, one second. If your teacher told you this angle, well then you would be able to know this angle and this angle and this angle. So let's go ahead and try that. So let's say, for example, this angle here is 120. Okay? So therefore, because this is a straight line and it's being intersected, I know that it should equal 180 altogether. That means this angle is going to be 60, because 120 plus 60 is equal to 180. Okay? And then now I can kind of take a look here and see that I have an F rule, because this right here is just like the letter F. If my drawing, my beautiful drawing, could indicate that. There you go. Well, then I know, based on everything we've just learned, that this angle has to be the same as this angle. So this and this have to be the same. And then obviously this angle, 60 degrees, is the same on this side. Right here. That should be a smiley face. Wow, really creepy looking smiley faces. Okay, you guys get what I'm saying though. So that is the F rule. Okay? Not the F word. Don't say the F word, it's bad. But the F rule. Okay, guys. So what's also important to understand is something called the alternate interior angles rule. Okay. Oops. So just double checking something here, you guys. Perfect. Sorry, I was just checking that the live stream was still working. Now, basically, what this rule tells us is that this angle, oh, again with these arrows, is that this angle and this angle, we'll call them A and B, together equal 180 degrees. Which is pretty handy because it's going to help us solve a lot of questions in this unit. So this is called the alternate interior angles rule. And a lot of people just refer to it as the C rule. Because, and I'll show you why. Let's go orange. Actually, I'm just going to make this fuzzier so that we can actually see what it is that I'm doing. So this is the C rule because this looks like the letter C. Kind of. If a robot was to write the letter C. Alrighty, guys? So, as you can tell, A plus B equals 180 degrees. Now, what is the reason for that? Well, again, it comes back to our supplementary rule. Let me just make that smaller again. And when I say that the reason is because of our supplementary rule, what I mean is that, again, let us picture a straight line, okay? And this straight line is being intersected by some other line. Well, I know that here I have these two angles, A and B. A and B that need to equal 180 degrees altogether. So if B is again like 130, then this is going to be 50. Well, let's now, just for the sake of it, pretend that we have an exactly parallel line coming in. And as you can tell, this creates a C rule. Let me get that down to 3. There we go. So this creates a C rule. This is an exactly parallel line to this first line that I used. So again, now because it's exactly parallel, the rule follows the exact same thing, because this is again going to be 50 and this is going to be 130. And if we look at it really closely, we can see, no pun intended, oh gosh. Sorry guys, each week, like at the beginning of this, my handwriting on here gets a little bit wonky, but we get used to it. There we go. So again, we have a C rule here, and it makes sense for the two interior angles to be equal to 180 because they are just the opposite sides of the intersecting supplementary lines. Okay? So if anyone has questions about that, let me know. Now, I'm going to teach you guys 2 more rules here that have to do with the letters, and then we're going to move on to some more complex questions and some more kind of just interesting rules in general. So I'll give you guys about 10 seconds so you can ask any questions that you might have about that stuff, and then we can keep going from there. Okay. So the 2 last rules that I'm going to show you, the first one is just the opposite angles rule. This one's pretty easy. So if you have 2 angles like this, and they are perfectly inset there, so this should be perpendicular lines. Let's just double check here. So basically, if this is angle, oh my gosh, this is angle A, and this is angle C, and then this is angle B, and this is angle D, then B is equal to D, and A is equal to C. Okay, you guys? So again, if this angle here is, for example, I don't know, let's say 120 just for the sake of it, then this angle also has to be 120. Okay? And the same thing would apply for B and D. So that's our opposite angles rule. And the last rule I'm going to show you guys, again, has to do with 2 lines that are parallel to each other. Again, parallel is the key word here. If they're not parallel, if you don't have any indication that they're parallel, and that indication looks like this, just a little kind of quotation mark, or sometimes it's just one line, that's going to be a problem. So these lines have some, oh gosh, there we go, have some intersecting line that looks like this, okay? And if you guys take a good look there, let's not use red, let's use pink again. If you take a nice, good, close look, you can see, that there is a Z formation that is apparent. And for those of you, if we have any American viewers, because I know that we had a couple people from the States watching, it's called a Z formation where you guys are from. Canada, we say Z, but we don't discriminate as long as everyone can understand. Okay, guys, so in the Z formation, there are a couple things that are important to note. So, which angles do you think would be the same? Well, logically, again, based on our rules that we were looking at before, I'm just going to change the size and the color here to, I think it was at 3. Okay. So if we're looking at this here, and let's call this angle A, well then, if you think about it, this angle here, which we'll call angle C, is the exact opposite. I mean, the exact same is what I'm trying to say. Because if you think about it, they're both the exact same interior angle. If we were to flip this one here over to the other side, they would be technically on the same thing in the interior angle. So then now we also have another thing that's true, which is that if this here is angle B, then this angle D is equal. So in this case, again, we have B equals D and A equals C. What's really, really important is that you understand the fact that basically your teachers are going to give you way more convoluted questions than this. And that's fair because realistically, the whole point is for you guys to be able to recognize these rules even when it gets more complicated. So my main tip is to practice the easier ones as much as you can, but really once you understand the rules on a deeper level, start practicing the more complex questions. Okay? So let me just open something up here. We're going to do a practice example quickly. So let me do some erasing, since we've got a perfectly good situation going so far. And let's say that, I don't know what my pen color is. Oh, it's blue. It's green, I mean. So let's say that this angle is 75 degrees and that this one is 120. Well, based on the rules we've learned so far, there are so many different ways that we can solve this particular problem. Okay? So first and foremost, if we want to solve it using, let's say, for example, the opposite angles rule, then I would know that this angle is going to be the same as this angle. So then this angle here is also going to be 75 degrees. Okay? And again, even if we didn't have that rule in place, if we go back to our rules over here, because basically when you get these kind of questions, your teachers are typically going to ask you to tell them which rules you used to solve, right? So if we look at our various rules, we have an F rule, we've got all kinds of fun situations going on there. So if I have an F rule, let's say that it's, let's call this the F rule, this right here, F. Oh gosh. My lines. My lines. Okay guys, honestly, my lines, I'm trying to get them as straight as I can. I promise. Okay, so given our F rule, we know that this angle is the same as this angle. So there we go. That's one thing we solved using the rules that we've had so far. Then, for example, we would know that using our C rule, which is like this, and I'm just going to increase the size here, this bad boy. So our C rule, that looks like this, we know that these two interior angles need to equal 180 degrees altogether. So I could literally just say to myself, well, what is 180 minus 120? That equals 60. So actually, I made a mistake here because this angle couldn't be 125. It would have to be 105. Sorry, guys. I got ahead of myself. This would have to be 105 because these two angles have to equal 180. So I was just using an example and I didn't mean to mess you guys up there. Give me a second. Okay. So this would have to be 105. But nonetheless, those same rules still apply. Now, if this is equal to 105, then let us erase this bad boy. Excuse me. Sorry, guys. I had to sneeze. So let's go ahead and just change this to the pen. So if these two angles together need to equal 180. Well, then 180 minus 105 is going to be 75, which makes sense because knowing all of our rules, F rule and everything, Z rule even, that's what the situation is going to be. So let's take a look here at the Z rule quickly before we move on, just so that we can incorporate all three into this example. So if our Z rule looks like this, and we know that whatever this angle is needs to be the same as this angle, then obviously that is going to be 75 degrees, which makes sense because it's opposite this other 75 degrees. So I could just use that information to my advantage as well, because then I know that whatever this angle is going to be the same as this. Okay, you guys. One thing I want to make very clear is that you can watch me do this all day, and it seems very easy when you're watching someone else do this kind of question. But these are really, and like most things in math, but in actuality, this is the type of question that you have to do and you have to practice. It's just like, you know, for example, becoming a great runner. You don't become a great runner by watching someone else run. I wish that was the case, because then I would just watch YouTube videos of people running and I would think that I'm a great runner. But in actuality, I have to go out and practice running if I want to be good at running. And math is exactly the same way. So the purpose of these videos and this live stream is to be able to have a forum where you guys can ask questions and be involved in the learning process. And then what I really recommend is practicing these on your own so that you can consolidate this information in your brain, and that if you ever get asked this stuff, it's really, really easy for you to remember that way. Okay? Alrighty, guys. So one other thing that we should be discussing in general is the interior angles of polygons rule. So we've gone over all of these angle rules, and there are more, don't get me wrong, but what I think is really important for us to understand is that when we talk about the interior angles of polygons, there's actually a method for us to be able to solve what the degrees of the inside of a particular shape should equal to. So let's start with a triangle, just because that's really the easiest one to kind of visualize. So if I have a triangle and he looks like this, it's a handy, fancy dandy little triangle, and I know the rule that I know the rule that all these angles inside this triangle need to equal 180 degrees altogether. Well, given that information, I can actually apply something that is called the interior angles of polygons formula to teach you guys how we're able to figure out what the angle needs to be in any polygon. So for example, you could have like a quadrilateral, and quadrilaterals come in many shapes, but this is an example of a quadrilateral. You could have a pentagon, which looks like this, kind of, if I was better at drawing shapes. Basically, it has 5 sides is what I'm trying to say. You could have a hexagon, like this. And using the rule I'm about to teach you, you could determine how many degrees are inside of these different shapes. So as we know, a triangle has 180 degrees. Well, would it shock you to know that every quadrilateral has 360 degrees, and every pentagon has 540 degrees, and a hexagon has 720? Well, how do we just randomly know this? It's like, what do I do to get these exact numbers? Very, very easy. And there's no need for you to memorize all of these numbers. Instead, we're going to use a rule for all of this to get us all of this information. So the formula goes, you take the number of sides of a polygon. So in the shape, in the triangle shape, we have 3 sides, obviously, this side, this side, this side. And basically, you subtract 2 and you multiply that number by 180 degrees. So this is a formula, guys, okay? So the number of degrees in a polygon equals 180 degrees times something that we're going to, instead of saying number of sides of a polygon, we're going to use the letter n to describe that, minus 2. So let's use this logic and this formula with the triangle. Well, we know that a triangle has 3 sides. Okay, just making some space here, you guys. We know that a triangle has 3 sides, okay? And I know it seems redundant, but I'm literally going to write that down. Triangle has 3 sides. You know, A, B, C. Which means that for a triangle, so number of degrees in a triangle, it would be 180 degrees times 3 sides minus 2. And this minus 2 always stays the same. This base formula right here, it doesn't change. All that changes is the n, because that represents number of sides. And I highly recommend writing this down. This can actually save you a lot of time in the future as well, because you're going to need to understand this concept throughout every grade realistically. But anyways, let's go ahead and use BEDMAS here. So 3 minus 2 is 1, which leaves us with 180 degrees times 1, which equals 180 degrees, which makes sense because we know that in a triangle, the 3 angles have to add up to 180 degrees. Okay? So I'll give you guys a second to write that down and ask any questions if you have them. And then we're going to move on and try this for another polygon just so that we can make sure that the rule makes sense for you guys. Alrighty, guys. So let's go ahead and try the same rule with a different polygon. So let's recall. Actually, I'm just going to do this on a new page because ultimately it'll give us more space. So let's go ahead and try this with a hexagon. So again, we know that a hexagon looks like a stop sign. Has 6 sides. The sides don't need to be perfectly equal. As long as it has 6 sides, you're going to have this rule apply. So a hexagon has 1, 2, 3, 4, 5, 6. And our rule here is that the number of degrees in a polygon equal 180 times the number of sides of the polygon minus 2. So if we use that same logic to solve here, we're going to say 180 stays the same because again that's part of the core formula. N is going to be the number 6 because we have 6 sides. And subtracting 2. So doing the brackets first because of BEDMAS, we get 4. So 180 times 4 is 720. Okay. So again, this rule basically tells us the sum of the interior angles. Because again, if I was to add all these angles up in the hexagon, they would equal to 720 degrees. The same way that when you add up all the interior angles of a triangle, they equal to 180 degrees. So why is this really, really important? Well, what this becomes as we get into the more difficult parts of this unit is a situation where you have to use this information in conjunction with algebra. And this is the part where a lot of people struggle. So the reason why we went over the fundamentals so thoroughly is so that I can show you guys an example of this where we're applying algebra to the situation as well. Alrighty? Okay guys, so let's go ahead and take a look here. So let's say I have this polygon. Let me erase that, sorry. I'm going to use straight lines here. So let's say I have this polygon. It's technically a quadrilateral, and quadrilateral, based on the word quad, means 4. And it's really important that you guys memorize those Latin prefixes, just because it will help you. So in this example, this angle is said to equal 2x plus 10. That's a 2. This angle is said to equal 2x. This angle is said to equal x. And this is 70 degrees. Well, this just got real crazy real fast. And this is why I wanted to go over this unit, because not because the concepts of this unit are difficult to understand. It's more the application of the concepts that becomes harder for people who maybe didn't get a chance to learn this in class, which I know that I would say probably most of you guys probably didn't get a chance to learn this in class, because most teachers leave this to be the last unit in case you guys don't get a chance to finish it for whatever reason. So I thought it would be pretty important for us to learn. Now, remember our sum of the interior angles formula is equal to, so sum of interior angles is equal to 180 degrees times the number of sides of the shape minus 2. So in this case, I have 1, 2, 3, 4 sides of this shape, which means that my n is equal to 4. So we go 180 times 4 minus 2, which is going to equal 2. And then from there, we're going to get 360. Okay. Well, that doesn't mean that we've answered our question, right? Because obviously we still have to solve for x. Because realistically, the question here is that they want us to determine the value of each unknown. Well, let's go ahead and do that. Alrighty. So if I know that all 4 of these angles have to equal 360, well then this just becomes an algebra problem. How do we set that up? Well, this is where our knowledge of polynomials comes into play, because what we're really going to do is just set these up polynomial style. So this is the first angle, 2x plus 10 plus 2x plus x plus 70 degrees, all equal 360, because again, we know that all of these angles put together need to equal 360 degrees. Well, let us go ahead and do that. I'm just going to move this up. And if anyone is writing stuff down, just let me know if I've cut anything off that you can't see, so that that would stop you from seeing. All right, guys. So what the real trick is here is to go ahead and collect like terms. So we're going to get rid of the bracket here. I'll show you guys this step in a different color. So this becomes 2x plus 10, again plus 2x plus x plus 70 equals 360. The reason I had originally put 2x plus 10 in brackets is because I like to have that as a habit, because sometimes those might be negatives. And it's important when they're negatives that we're very careful about how we add them to an overall formula like this, or a statement basically. So now we're going to collect like terms. And if you remember, if you were watching on that first week, we talked about what is a like term. Well, here we have 2 types of like terms, and we're going to circle them in different colors just to show you. So I have an unknown value attached to a coefficient, but really just the term that is an unknown value to the power of 1. So here x is to the power of 1. These are going to come together. So this is going to become 2x plus 2x plus x. And I highly recommend using this circling method. It's really an easy way to just make sure that you've got everything that you need. Great. And then we've got this lavender color, and we're going to bring together our numbers. So we have positive 10 and positive 70. And again, it's really important that we keep the signs the same if it's staying on the same side. So this is going to become positive 10. Trying to do a plus sign. There we go. Positive 10 plus 70. And then all of that still is equal to 360. And now we just bring our like terms together. So 2x plus 2x plus x is going to be 5x. And then so positive 10 plus 70 is going to be 80. And again, that's going to equal 360. And now we just solve algebraically. So I'm going to use a totally different color for the algebraic solve. So I want to bring 80 to the other side, and that's going to become 5x equals 360 minus 80. Okay, guys? So that's going to be 5x equals 280. And then we want to get this 5 off of the x, because we want x to be by himself. We want him to be in quarantine. So we're going to divide 5 off because, and again, if you're confused by how this algebraic stuff works, I highly recommend going back and practicing algebra as much as you can. All of the rest of math is based off of algebra. And so if you're struggling right now, I really recommend taking these next few months to practice algebra as much as you can. Okay? And again, like you guys know, we are actually a tutoring company, and we do provide online tutoring. If it's something that you've really been struggling with and you find that you can't get to it, you haven't been able to understand it on your own, please feel free to reach out to a tutor. We can create a plan for you that gets you prepared for grade 10 math and actually pre-teaches you grade 10 math so that you can be fully ready for next year without any hesitation whatsoever. So that is something available to you if you'd like. Okay, shameless plug over. 5 divided by 5 is 1, so we're left with 1x, and that's what we wanted. So all that's left here is x equals 280 divided by 5, which is 56. So this is our unknown value, 56 degrees. Does that mean that our question is over? Probably not, because we still have to figure out all of the different angles. So given this information that x is equal to 56, let's go ahead and label these angles. We're going to call this one angle A, this angle B, this angle C, and this angle D. We obviously know what D is, so we're just going to keep that as 70. Now, in terms of the other ones, let's do them piece by piece. So if we've got angle A is equal to 2x plus 10, and we know from our answer over here that x is equal to 56, I'm just going to plug in 56 there. So, just keep that same thing. So then this becomes 2 times 56 plus 10, which is equal to 122. And then, so that's part of the answer. Then if we're going to try to solve for the other angles, we've got B, which is 2x. So we're just going to solve that. So B equals 2 times x. And that would be 2 times 56, which is equal to 112. I could probably do this a little bit neater. So if you guys are doing this on a test, I would recommend doing this a little bit neater. And then C is equal to x. So C is just equal to 56 degrees. And remember, always state your answers in degrees. So you might want to write this as angle A is equal to 122 degrees, angle B is equal to 112, angle C is equal to 56, and angle D is equal to 70. And now you've solved for all of the angles using algebra, but most importantly, using our sum of the interior angles rule, which is really the key here. Because if we don't understand that this is how we can solve for this kind of stuff, you won't even be able to get to the algebra part. Okay, so I'm just going to kind of leave that like that. And I'll let you guys take a look there. And as always, if you have questions, just let me know. Alrighty. So what we're also going to do here is solve another one of these more difficult ones. And I'll show you guys what I mean. So let's say that we have something like this. Okay. And that they've given us some of these angles. Let's use purple. So let's say they've given us 30 degrees. Oh my gosh, I hate when I do that. There we go. Say they've given us 30 degrees and 120 over here. Oh, nope, not that. 30, this is 80. And they want to know these unknown values, x and y. Oh, y is on the other side. So one rule that we didn't get to discuss yet is that actually when you have an angle like a triangle situation like this with a little stub part sticking out, and I'll show you what I mean. So when you've got this angle, and then a third angle out here, but technically it's all kind of part of the same triangle situation. Basically, this angle A plus B is equal to C. And this is the exterior angles of a triangle rule, also called EAT. So I'll write that down for you guys if you want to copy it. As I said, it's also called EAT. And really what the rule is that A plus B is equal, this should be dots, is equal to C. Okay, let me make that into dots. Dot, dot. Okay, so in this case, we would have 30 plus 80, which would equal C. Alrighty, guys, and that's going to be 110. So this angle here is equal to 110 degrees. And then using another rule, the opposite rule, we can solve for this x, because if this is 30, then this also is going to be 30. Okay. All right. So let us keep on trucking, keep on rolling. Now we're going to take this same rule that we just learned and do something somewhat similar. So let's take a look here. Let's see if we have, I want to see, is there like a version of this that's literally just a straight line? Because that would be preferable. Not this. There must be. They've got all these crazy things. Like there's a thermometer and an umbrella, but not just a plain old straight line. Well, that's annoying, but that's okay. So we've got this straight line, and we've got two triangles on here. So we've got this one, and we've got this bad boy. Okay. So this one has a 90-degree angle right here, which I'm going to show using my little square. And what's very interesting about this problem is that this line is parallel to this line. And we love those parallel lines, right? They are going to tell us that this angle is equal to 80, this is equal to 120, and that they also want to know this angle x. Okay, so using our exterior angle rule, EAT, which we learned here, remember that the two angles in the triangle that are opposite the third angle, but on the other side. I'll show you what I mean. So for example here, I'm going to use a different pen color because I'm fancy like that, you guys. So if I have this angle, and we'll call this A, and I have this other angle that I don't know yet called B, and I know that this angle is 120, well, I know that using our eat rule, because you always got to eat, that A plus B is equal to 120. And therefore, I know that 80 plus some unknown value is equal to 120. So how can I solve for B? All I have to do is algebraically rearrange this. So this is going to become B equals 120 minus 80, which is technically equal to, well, not D. This is going to be equal to 60. So I know that this is 60 degrees. Okay. There are a couple different ways that we can solve for this x. The easiest way is actually to solve using the rules that we've learned all this time. Oh, I want to make that purple. So if we know that these are two parallel lines, then we don't have to just picture them as ending where we see them end here, right? We can picture them using our rules. Oops. Okay. So, if anyone has any questions about what I've done so far, just feel free to let me know, okay, guys? Now, keeping this in mind, we've got a couple of things that we can think about here. So we know, ow, sorry, my eye is hurting me. That again, this can continue on. And that this could realistically be used in a bunch of different ways. Okay. So, first things first, technically, we could look at this as an F rule, right? Because this line here is intersecting these two purple lines. And I know that if this is an F rule, let me erase some of this stuff. Whoops, just gonna erase. So we only got 2 minutes left, but I want to make sure that everyone understands what I'm talking about. So again, if there's something you're confused by, just let me know. So this is going to be 120. Okay. Oh, sorry. 100. Because 180 minus 80 is going to be 100. And then I know that over here, using my interior angles rule, that this is also going to be 100. Oh, sorry guys, 1 second. Whoops. All right, so if we've got that, then we know that, sorry, using our other rule, our Z rule, this is going to be 100. This is going to be 80. And we also know that this here sorry guys, this eraser is not small enough for me to actually show you what I'm trying to show you. Now a couple other things. If we know that this angle here altogether needs to be equal to 180 degrees, then this plus this is going to tell us that this is 40, and then on this side this is 40, because they're opposites of each other, which means that here we're left with 60, and if this is a straight line, then this is also 120. So I know we kind of just zipped through that part there, but feel free to watch this back on YouTube later. It'll be uploaded to the YouTube channel, and it'll make a little bit more sense for you if you're able to start and pause it and stuff. And if you do have questions, just feel free to come back next week and ask them, and I'm happy to go over this stuff if anyone is confused. But that is actually everything for our grade 9 class today, you guys. Thank you so much for joining. If you want to submit questions for next week, as always, you can always submit them at admin@scholarlyelite. Let me just type it, it'll be faster. admin@scholarlyelite.com, and we will answer them on the live stream, or you can, as always, submit them through the live stream chat next week as well. Okay, guys, have a wonderful week, and we're going to get started with our grade 10 class. So thank you very much for joining. So if you're here for the grade 10 class, I want to say welcome, and I hope that you have been having a wonderful week so far. I'm just going to grab my grade 10 materials here, because I try not to come up with stuff on the spot. It's just better for everybody. So we are having a trigonometry theme here on freemathhelp.ca this week, you guys. And so what we are going to do in the grade 10 class today is learn about the kind of primary trigonometric ratios that are really, really important for all of the rest of math, especially if you're going to go on to grade 11 functions and grade 12 advanced functions after you're done grade 10. So without further ado, we're going to get started. Let me just pull up one thing. So I know that we are all familiar with the concept of the 90-degree triangle, or also, which is also denoted as the right angled triangle. As we can see here, it literally has a right angle which is equal to 90 degrees, and we can take that information and use it to our advantage in a number of ways that I'm going to show you guys today. And then hopefully, like after the lesson, we'll be able to do some very good practice examples so that you guys can get a good understanding of how these questions might be asked on a test. Okay, so you guys, I'm trying to talk a little bit louder this week because I know that when I watched back the live from last week, that my voice was a little bit low and not everybody has great speakers. So I'm going to try to talk louder. So if I'm talking too loud for you, I'm sorry. Just please turn it down a little bit. I just want to make sure that it's fair for everybody so people can actually hear. But without further ado, let's get started. So one really important concept that we need to understand about a right angle triangle, if you guys recall the concept of the Pythagorean theorem, we always talked about this length, this side length from here to here is called the hypotenuse. And I honestly feel like I'm spelling that wrong. Give me 1 second, you guys. No, I'm spelling it right. It's just a weird word. Just a weird word. Anyways, not the point. The point is that this and the knowledge of which angle, which side length is the hypotenuse is very important. And for those of you guys who might want a bit of a refresher, just the main thing I need you to understand is that it's always, always, always the side length across from the 90-degree angle, okay? Now, what we're going to learn about today are the primary trigonometric ratios. So let me just type that. Trigonometric ratios, which are a really, really important concept in math. And for those of you guys who are going, like I said, if you're going on to the higher levels of math, you really have to have a very, very strong understanding of these ratios. So when we talk about the primary trigonometric ratios, before we get into anything, I want you guys to understand that what this really is saying is that ultimately, no matter how you slice it, the rules of a right angle triangle are always the same. But it does depend on which angle you're trying to solve or which angle you're talking about. So let's say, for example, we're going to name these angles A, B, and then this one can be C. Well, we already know C, it's 90 degrees, and that's going to be a given. Your teacher's going to tell you whether it's 90 degrees or not. What is important to us is whether we are discussing angle A or angle B. because that changes the situation a little bit. So let's say that in this case, we are discussing angle A. Okay? Now, what's really important is that we understand which side length is right next to angle A and which side length is opposite of angle A. So naturally, we know that this is its opposite. And that this is right next to it. So we're going to call this adjacent. Now, these terms are things that you're going to have to memorize because we're going to use this terminology in the formulas that I'm going to teach you. And it's very standard. So no matter what school you go to, whether you're Canadian, an American, whatever, you're still going to use these terms because that's how these rules go. So I don't know if you guys have ever heard the term SOHCAHTOA. And if you have, that's awesome. But it looks like this. SOHCAHTOA. This is terminology that I highly recommend you memorize. Just the word SOHCAHTOA. It's not really a word. It's kind of an anagram or whatever those things are called. Actually, I don't even think anagram is the right word. An acrostic almost, in a way, but not really. And I'll show you what I mean. Basically, again, the first thing you need to ask yourself is which angle are you trying to solve for? So if in this case we're solving for angle A, right, we can use what we call the primary trigonometric ratios to tell us what angle A is. And those trigonometric ratios take into account side lengths. Okay? So let's break this down. SOHCAHTOA can be further broken down like this. And I'll show you what I mean. We have something called sine, and you're going to see that it looks like this, sine of theta. Theta means angle. So this is a Greek letter. We pronounce it as theta, but what it really means is angle. And what it's actually saying is it's an unknown angle. So, and again, this isn't going to make sense all at once. It takes some time, and it's going to take us kind of walking through what the steps are and what it all means. So don't feel, if you're feeling confused right now, don't worry. That's okay. We're going to go through everything. And if you have questions, you can definitely drop them in the chat or email them to us, and I'm happy to address them either this week or next week. But here we have sine of theta. So the S comes from sine. Okay. Now, what does this mean? Well, we can solve for this angle theta through some steps by using the side lengths. So if we have the length of the opposite side of that angle, and we know the length of the hypotenuse, we can solve. So as you can tell, the letter SO comes from S, O, H. So sine of theta equals opposite over hypotenuse. This is always, always, always true. Okay, you guys? Very important to remember. So let's look at the next trigonometric ratio. We have cos of theta. And again, I don't expect you guys to understand what sine and cos mean just yet. I have to show you these first, and then we're going to talk about how we use them and what they mean. So again, cos of theta, and the theta in this case that we're solving for is A. We have the ratio is equal to adjacent over hypotenuse, meaning we're going to use the adjacent side length and the hypotenuse length to tell us very important information about that angle. And then TOA represents tan of theta. So again, the tan of the angle is equal to adjacent, oh sorry, my bad, opposite over adjacent. Alrighty, you guys, so these are three different things, but they all accomplish a similar goal, which is to either solve for the angle or conversely to solve for the side length. It just depends on what the teacher's asking for. So we are going to use these ratios to both solve for the side length and to solve for the angle. So give me 1 second. I'm just gonna get these like written down because it's just easier for us to use all the time. And I do have them on my computer, but it's just gonna be easier this way. Okay, let's go here. Alrighty, guys. So, just so that we can have them available to us at all times. Now, let's go ahead and use this information to our advantage. And let's remember that theta and sine are not the exact same thing. So sine, for example, is a function, and I'll show you what that means. So if you have your calculator in front of you, what I want you to do is I want you to press sine, or sin. It looks like sin on your calculator, S-I-N, but it's pronounced sine. And then just the number 45. And I want you to press equal, and you're going to get 0.707. Or you could go ahead and do sine of 30, and that'll equal 0.5. So I'm going to show you what this all means, okay? But again, if anyone is copying down what I'm writing, just take a second to write all that down, and then we'll move on in just a moment. So these are called our primary trigonometric ratios. There is such a thing as secondary trigonometric ratios. There are trigonometric equations and expressions, and this unit expands on itself beyond belief. So that's why I'm a big believer that in grade 10, it's so important to understand the core fundamentals behind what's going on here, so that later on you have the full capacity to understand the next part of the unit. Okay. Now, let us go ahead and explore what this all means. So let's say, for example, we're picking up another one of these, and we're just going to expand it so that everyone can see. So let's say, for example, we've been given the side lengths 10, 6, and 8 here, and that I have some unknown theta right here. Well, if we recall our trigonometric ratios, I'm just going to get rid of So remember, sine of theta is equal to opposite over hypotenuse, cos of theta equals adjacent over hypotenuse, tan of theta is opposite over adjacent. So what does this mean to us? Well, what's really important to understand, and I'm going to erase this triangle here so that this makes more sense. And I'm going to enlarge this image if I can. Oh, not what I was trying to do. Oh, that's how the eraser works. Interesting. Did not know that. That's okay. Anyways, hopefully you guys, I think you can see that if you have your screen on full screen. Now, again, when we talk about opposite, hypotenuse, adjacent, these terms refer to side lengths, okay? So that's really important to remember. And remember that the side lengths are subjective, which means they vary in terms of their names based on which angle in the triangle you're talking about. So if I'm talking about this angle right here, then I need to talk about the opposite, adjacent, and hypotenuse with regards to this angle. One good thing is that the hypotenuse is always the hypotenuse, meaning it's always the side length opposite of the 90-degree angle. So we know that this is the hypotenuse, which I really don't like the spelling of this word. I feel like it should be spelt differently. But anyways, and since we're talking about this angle, then we know that the opposite is the one across from it. So that's going to be the number 8 here, the side length that is 8 units long. And the one that's right next to it, and if you haven't heard the word adjacent before, it literally means something that's right next to something else. So adjacent to this, it's right here. Adjacent. Great. Now, a lot of times teachers will have you just use the letters because it makes everyone's lives easier. Now, we can use our trigonometric ratios for a number of things, but let's go ahead and plug this in. So sine of theta is equal to, remember that sine of theta is equal to opposite over hypotenuse. So we're gonna take the number 8, which is our opposite length, and the hypotenuse, which is 10. Now, we're just going to leave it like this for a second. I want us to understand what this means. And actually, what I'm going to have us do, I'm going to move this over a little bit. So sine of theta is equal to opposite over hypotenuse. And remember, if you're having a hard time remembering this, it's SOHCAHTOA. Some teachers use like a rhyme or something. I just find just memorize this word and you'll be much better off. SOHCAHTOA. Okay. So opposite over hypotenuse, which equals 8 over 10. Let's look at cosine of theta, which is equal to adjacent over the hypotenuse. And that in this particular case, is going to be 6 over 10. And then we have tan of theta, which is equal to the opposite over the adjacent, which is 8 over 6. Oh, let me write the letters. So opposite over adjacent, which like I said is 8 over 6. Okay, one thing that's really important to remember, even if I was to plug in, for example, sine of theta equals 8 over 10, that's not the answer for the angle. That doesn't tell me what the angle is. And I'm going to show you guys how we can actually get the angle. Instead, what it tells me is the sine of the angle. And I know that, again, this is kind of hard to understand when you're first learning it. You'll see what I mean as we go on and we practice this more and more and more. But just remember that sine of theta, whatever that is going to be, it's going to be 0.8, obviously in this case. That's not the angle, which makes sense because obviously your angles need to equal 180. So clearly they're not going to be opposite over adjacent. Yeah. This is going to be 1.3. So obviously 0.8 plus 0.6 plus 1.33 is not going to equal 180. That doesn't make sense. Instead, these are just functions that tell us something about the angle. Now, there are ways to solve for the angle, and I'm going to show you guys how to do that. But what's important to understand is that these are not the angle answer. Okay? So let's do step by step. We're just going to leave this as it is right now. We're going to move on to the next piece of this so that we can finally get to what it is that we're trying to solve. So let's say we were given a question like in a right triangle, I mean, if cos of theta is equal to 12 over 13 and tan of theta is equal to 5 over 12, what is the value of sine of theta? It's an S. And this is a really common question that I've seen on a lot of tests, so it's really good that you guys have an understanding of what the heck this is asking. Alrighty, so let's recall what our trigonometric ratios are. So SOHCAHTOA. And what do they refer to? Well, they refer to a right angle triangle and they refer to a specific angle. So again, if this is my right angle triangle, this is my hypotenuse. And let's say, just for the sake of it, instead of this top angle, we're actually talking about this angle. So Now, because we're referring to this angle specifically, we need to refer to the side lengths relating to this angle. Well, what's the opposite? The one across from it is going to be here. And what's the adjacent? The one right next to it is right here. Great. So, having all this information in mind, and remembering that this equals sine of theta equals opposite over hypotenuse, and that cosine of theta is equal to adjacent over hypotenuse, and tan of theta is equal to opposite over adjacent, then knowing all of this, then we actually know that the question has given us quite a bit of information, because they've told us that cos of theta, aka the cosine of this particular angle, is equal to 12 over 13, and that the tan of theta in this particular case is equal to 5 over 12. Well, let's break this down even further. What is really important to note? Well, that the fractions refer, the numerator and the denominator of these fractions actually tell us the side lengths of the triangle. Because if we think about it, cos of theta is equal to 12 over 13, right? Well, what's another way of saying cos of theta? Well, we know that cos of theta is equal to adjacent over hypotenuse. Over hypotenuse. Well, that tells me that this side length, let me just move this up a little bit, that this side length is 12, and that this side length, the hypotenuse, is equal to 13. And now I see what it is that's missing here. Give me 1 second, you guys. There we go. I knew something was looking odd on the screen today. Okay, so now we also have another piece of information, and that is that tan of theta is equal to 5 over 12. And we know that that makes sense because tan of theta is equal to opposite over adjacent. And we already know that we solved for adjacent in the last part, and we know that adjacent is 12, which makes sense, right? So now all that's left is to solve for opposite, which is 5. That means that we've got all 3 side lengths of this triangle down pat. We know that this is 13, we know that this is 5, and this is 12, because that's how they relate to the theta that we're solving for, to the angle that we're solving for. And now what they're asking for is, what is the value of sine of theta? That is really simple because we know all of these other parts of this question. And we know that sine of theta is equal to the opposite over the adjacent. Oh, my bad. Sorry, guys. I was reading the wrong thing. Over the hypotenuse is what I'm trying to say. And we already know those 2 side lengths. So we know that because we're solving for this particular angle, the opposite is 5, which we found out from our tan earlier. And we know that the hypotenuse is 13. So sine of theta is 5 over 13, because that's what the opposite over the hypotenuse is equal to. Okay. So if anyone is confused by that, please feel free to let me know in the chat. I'm happy to address anything that might be confusing you. So we're going to go ahead now and further apply this knowledge. I'll give you guys actually like a couple seconds to write that down if you want. So let's go ahead and apply this knowledge even further. I'm hopeful that today we're going to have time to actually show you how to solve for the angles. But let's say we were given a question like this. Say I asked you about this triangle. I told you that we are solving for this. Actually, you know what? We've been solving triangles that look this way the whole time. I'm gonna flip it. So it's gonna be like this. Because again, you're gonna get triangles, all sorts of different variations. It doesn't really matter what the shape. What the kind of positioning of the triangle. All that matters is the right angle triangle. So let's say we're solving. We have this is A, and this means angle A. This is angle B, and this is angle C. And let's say, for example, you've been told that this is I don't know, 58 degrees. Okay. Now, again, it's really important that we determine which side length is which in terms of the name of the side length based on the specific angle that we're talking about. But we're always going to have the hypotenuse stay the same, regardless of if I'm talking about this angle or this angle. The hypotenuse is always in the same spot because the hypotenuse has to be the side length that's across from the 90-degree angle, which is right here. Because again, these ratios really only apply, or they actually only apply when we're talking about right angle triangles. Otherwise, if you don't have a right angle triangle, these ratios don't work, okay? So remember, we're talking about this right here. So we've got 58, and then we've got, instead of actually having the side lengths with names on them, oftentimes your teacher's going to give you stuff like B, C, A. How do they determine these letters? Well, if your angle is capital B, then the side length across from it is going to be lowercase b. If your angle is capital C, the side length across from it is going to be little c, and you have capital A, side length across from it is little a. Okay, so in this case, if they've asked you to solve for tan of 58 degrees, and they said, which of the following, like, how would you describe this ratio? Well, in this case, you haven't been given any numbers, so the only way we can describe this ratio is using side lengths. And the best way to do that is to first denote which side lengths are which based on this particular angle. So in this case, again, like I said earlier, this is the hypotenuse. Now, because we're talking about 58 degrees, the angle opposite that is the C. And here we have its adjacent angle. Perfect. Oops. Oh my gosh, there we go. Great. So, in this case, all I have are these letters to go off of, but what I need to know is my SOHCAHTOA rule. So, SOHCAHTOA. So, which letters are involved in tan? So, TOA. We have opposite, and we have adjacent. So here we've got opposite over adjacent, and in this case the opposite is the C and the adjacent is A. So this is our final answer in this case. Okay? Now, let's get into how to actually solve these side lengths and how to actually solve the various information that's been given. Okay, so before we move on to anything else, I want to make sure of one thing, and that is that I tell you guys about the fact that this whole unit has a very, very strong basis in algebra. If you are confused by how to solve for unknown variables in fractional algebra, I highly recommend you go back, practice algebra worksheets before you get into practicing for this unit. It will make your life so much easier. And I'm a big believer that letters really confuse, not a big believer, but just in my experience over years of tutoring many kids, I've seen how much the letters involved in this unit mess people up. And really, they're not any different than unknown variables. So if you understand that and you have a good grasp of algebra, you'll be much more calm as you're approaching this unit. Okay, so we've got to figure out how we can determine the side lengths and angles in right angle triangles. So again, I'm just going to pull up this bad boy here. So let's say, for example, and again, actually what I should say right now is that if you don't have your calculator in front of you, please go grab your calculator. It will make much more sense because I'm going to show you guys how to do this on your calculator. And if you don't have it with you, it'll make this much more difficult. Okay, and I know that everyone has a different calculator, but the rules that I'm going to show you apply for pretty much every single calculator out there. Alrighty, so let's take a look here. We've got this angle that we don't know. We'll call him a theta as we do. We know that the hypotenuse is 15 meters long and that this here is 6 meters long. So what we want to do when we're dealing with a situation like this, and when we are dealing with something where we're solving for a particular angle, in this case we're solving for this angle, we want to label the triangle with regards to that particular angle. So as always, the hypotenuse doesn't have anything to do with anything else. It's always the side length that's across from 90 degrees. But after that, the other two side lengths are written down based on which is which. So if this is this, then obviously if we're worried about this angle, the opposite side length to that is here. Wonderful, wonderful. So let's go back and talk about SOHCAHTOA, because again, that's a whole part of this unit, is just determining which of the ratios to actually approach and use. So if we've got SOHCAHTOA, this guy here, what's very important for us is to go ahead and determine what do we have and what do we need. In this case, they want us to determine the measure of the angle to the nearest tenth of a degree, and I'm going to show you guys how we can do that. But first we need to figure out which of these three we have the right stuff for. So process of elimination is the easiest way to do that. In this case, you're going to say, well, how many, which side lengths do we actually have? Well, I have the opposite and I have the hypotenuse. So which of these ratios has that? Well, I know that sine is equal to sine of theta equals opposite over hypotenuse. And easy enough, we can take that information and use it to our advantage. So we're not going to worry about cosine and tan because they don't matter to us right now. So let's go ahead and set this all up. So sine of theta is equal to opposite over hypotenuse. Well, the opposite in this case is 6 meters, and the hypotenuse in this case is 15 meters. And I'm not going to put the units in just yet. So in that case, we know that this is equal to 6 over 15. Well, this is now the step where we're going to isolate for theta. And technically what's happening is we're dividing off sine. But the way that it's going to show up for you guys on your calculator, and the way you're going to get this by itself, it's going to look like this. Sine to the negative 1 is equal to 6 over 15. Or sorry, sine to the negative 1 times 6 over 15. So I want everyone to grab their calculators, and you're going to look on your calculator, and where it says sine, you'll see above it, there's a little inscription that says sine to the power of negative 1. The way that we access that is by pressing shift and then press sine. And you'll see on your calculator it shows up as sine to the power of negative 1. And now all you've got to do, you can put brackets, you don't have to put brackets, whatever you want, but I prefer putting brackets. And don't press times or anything else. Just leave it as it is, put a bracket, and then type 6 divided by 15, and then close the bracket. And you should get 23.57. And what we usually do at this point is round to 23.6. And that is the angle right here. That's the answer for the angle. Okay, you guys? If anyone is confused, feel free to drop a question in the chat. But again, if you're writing this down right now, I want to reiterate that the way you access sine to the -1 on your calculator is by finding where your sine button is. Don't press it yet though. First, press shift and then sine, and you'll see that you'll get sine to the -1 on your screen. And then just put a bracket and type in the letters, the numbers 6 divided by 15, close the bracket, press equal, and you'll get your answer. So if anyone is confused by that, please let me know. I'm happy to go over that. What I am going to show you quickly as an aside is something that no math teacher has ever shown anyone, but that I actually have shown a lot of my students and they found helpful because a lot of people want to know why things are happening. So what's really happening is that this is like algebra. So in this case, if we have sine of theta and it equals 6/15, right? What I'm going to do quickly is I'm actually going to turn 6/15 into a decimal, which I don't usually do, but just for the sake of showing this. So it's going to be 0.4. So what's really happening here, to isolate for theta, what we have to do is divide off sine. And just like in algebra, which is what's happening here technically, is that we're dividing sine off of both sides. Here, sine divided by sine is going to equal 1, and we're left with theta. But now, I've got a situation where I have 0.4 over sine, and that's not helpful to me. Well, technically here, sine is to the power of 1. And just like any time we have an unknown variable to the power of something in a denominator, we can actually move it to the other side and make it to the power of -1. So I'll show you what I mean. So by moving it into the numerator, this becomes sine to the -1 times 0.4. And that's how we're solving our answer, which equals 23.6. So this is something I wish the teachers had shown me, because I'm the kind of person that likes to know why math problems are the way they are. And I find it much easier to understand. You don't need to type out, like the stuff I have in orange here, you don't actually need to write on a test or on an assignment. This is more just me showing you why what we have on the left side is the way that it is. Okay, so I'll let you guys write that down if you want. Give you guys a couple more seconds, and then we will move on. And if anyone has questions, feel free to drop them in the chat. And I know that some people don't want their names to show up in the chat. That's totally fine. If you want to email your questions to us, I am checking our email as we go along. And if you're watching this after we've posted it on our YouTube and you're not here for the live stream, feel free to send us any questions that you have to our email address, even if they're questions that don't have to do with this lesson. If you want us to address them next week, we're more than happy to. Okay. So it doesn't look like we have any questions, so we're going to keep on trucking here. So, continuing on this train of thought, in general, what's going to happen here is that you're going to be asked to solve different triangles, different side lengths, different everything. So I'm going to show you guys how to solve for different things. But actually, you know what? We're going to go back quickly So we have this exact thing, right? I'm going to erase this now. And what we're going to do is, actually, you know what? No, because that's just going to confuse you guys. So I'm going to stick to something else. Oops, there we go. Perfect. Okay, so again, let's say we have this triangle. He's a baller, just chilling. And we've got, this is 33 degrees. And we've got 12 centimeters. And that is the only information that your teacher has given you. Now, obviously, there are a couple things that are missing here. If we have, for example, this is x and this is y, we don't know this side length or the hypotenuse. We also don't know this angle just yet, although that's pretty simple to solve because we know that all three angles have to equal 180, so that's not a big deal. But so this one is pretty simple, and I'm going to show you guys kind of how we can use the information that we've been given, which is the 12 centimeters and the 33 degrees, to our advantage in a situation like this. So there are a couple different things that you can do. You actually don't need to solve for this angle in order to be able to solve for these side lengths. But just to be safe, because they want us to solve the whole triangle, and when they say solve the triangle, they mean solve every single unknown variable. So we're going to go ahead and solve for theta, that's over here. So theta over here is equal to 90 degrees plus 33 degrees plus, oh sorry, my bad, is equal to 180 minus 90 plus 33. And if anyone's confused by that, just let me know. So in this case, we've got 57 degrees. So that's our theta. Does that solve the side lengths for us? No, it does not, but that's okay. We're going to go ahead and solve the side lengths for ourselves. So again, remember, we've got SOHCAHTOA, and SOHCAHTOA tells us a lot of information if we know how to use it properly. So what I want us to understand is, what angle do we have? And in this case, I mean, we have all three right now, but the angle that I'm worried about in particular is going to be 33 degrees. So I want to solve for the different parts of this triangle using that information. Well, in this case, I know that this is the hypotenuse. It always is going to be the same. It's always the one across from the 90 degrees. And I know that this is opposite of 30, the side length is opposite of 33 degrees. So we've got that. And then this is our adjacent. Right here. Yay! Okay guys, this is really good. We've got everything labeled, and that's really what our first step is always going to be, is labeling as much stuff as we possibly can, because then we can take this information and use it to our advantage. What is going to be important to us? Well, I know now that I have the opposite side length, so I'm going to go ahead and look at which of these three trigonometric ratios have the O in them for opposite. So that's going to be sine and tan. And in this case, I'm going to go ahead and use tan. So I'm going to say tan of 33 degrees is equal to, and again, keep in mind your letters. So tan is OA. Well, that means it's going to be opposite over adjacent, which in this case is going to be 12 over some unknown variable x. Well, that's no problem, because all I need to do is start solving algebraically. So I'm going to rewrite this just so it makes a little bit more sense. Tan of 33 degrees is equal to 12 over x. Well, the only unknown variable that I have here is my x. That's it. And so if I'm just going to go ahead and solve, all I need to solve is for x. So a couple people that I've tutored have liked to plug in tan of 33 first, and I actually don't suggest that. I suggest leaving tan of 33 as it is until the very end, because it's going to be better than having to write down decimals every step of the way. One thing I do want to show you guys though is that you could literally plug tan of 33 into your calculator and you should get 0.649. If when you plug tan of 33 into your calculator and you don't get the answer 0.49, what you need to do is go and change the mode on your calculator. So at the top of your calculator, you should have a button called mode. Keep pressing it until you see degrees, or it'll be short form. So it'll say deg, rad, gra. And what this is that you want to put your calculator into degrees mode, because we're up until grade 12, we work in degrees. Now, what we're going to do is literally type in, or not type in, but press the word tan on your calculator, press 33, and press equal. You don't need to do tan times 33. No, you just press tan, 33 equals. It'll do the operation itself, and you should get 0.649. Now, like I said, don't do that yet. I just wanted to show you guys that that's what we're going to do eventually. What I want to do now is that this is basically an unknown algebraic equation. I'm going to show you guys how to simplify this without confusing yourself. So let's say that this is the same thing as saying, let's say, for example, 50 equals 500 over x. Well, how would you solve for x? All you would do is multiply x up, because right now 500 is divided by x. The opposite operation is multiplication, so it's going to become x equals 50. Sorry, x times 50 equals 500, which we can rewrite this as 50x equals 500. And then what do? We just divide off 50 from both sides. And we get x equals 10. Now, using this same exact logic, and honestly, this is the reason I showed you guys this is because in my many years of tutoring, this has been the part that people find the most confusing, because they forget that this is just basic algebra because of all this extra letters and numbers garbaggio. So that's why we will always make things as simple as possible by showing the simpler way first and then copying those same steps. So in this case, it's going to be x times tan of 33 degrees equals, that's a degrees sign, equals 12. And again, if you found what I did on the right there confusing, I highly recommend going back and practicing algebra. It's going to make this unit a lot easier for you, and this is not a unit that goes away. You have to understand this stuff for grade 11 and grade 12, and it gets more complicated in those years. So if you're struggling right now, this is the perfect time. Just because you're finding it difficult doesn't mean that it's hard or not doable. It just means that you're only being introduced to it now, and it looks more complex than it actually is. You are capable of doing this, I promise you. Just practice your algebraic formulas and algebra in general, and you'll be much, much more equipped to handle questions like this. Okay, so now what's going to happen is I'm going to divide off, just like I did here. Just like here, I'm going to divide off tan of 33. So if I have x times tan of 33, to divide that off, I'm going to divide tan of 33 from both sides. Great. These two cancel, and I'll just move this up a bit. And what is left? Well, all we have left on the left side is the letter x, which is what we wanted. And on the left side, we have 12 divided by tan of 33. Now, this is actually very easy to do on your calculator, and you can do it all at once. Just press 12 divided by bracket tan 33, close bracket, equals 18.47. Which realistically we're going to round to 18.5, and that is our side length for adjacent. So that's actually the answer to this side length. Okay, you guys? If you're confused by anything I just did, just let me know. But again, the part that confuses most people is the rearranging. But if you actually go ahead and do these same steps and pretend that you're just using numbers instead of all these letters and things, it will actually make your steps a lot more clear. So I'll leave that up for about 5 seconds for you guys to take a look. Okay, you guys. So hopefully everyone had a chance to write that down. We are going to try another type of problem. Well, actually, you know what? Let's just look at this here and let's finish up this problem in general to solve the whole triangle. So once I've gotten to this point, it's actually pretty easy to solve for the rest of the triangle because I can just use the Pythagorean theorem. So I'm just going to put in my side lengths. First, I'm going to erase this because it makes mess. You have to make a mess. So now instead of x, I'm going to do 18.5 centimeters right here, meaning I know 2 of my 3 side lengths, and I know that my Pythagorean theorem allows me to solve for the next part. So if everyone recalls, our Pythagorean theorem is a squared equals b squared plus c squared. Different teachers put these letters in a different order, but basically a squared represents the hypotenuse squared. So in this case, we don't know the hypotenuse and we know the other two, so I'm just going to plug in 12 squared plus 18.5 squared. And what we're going to do now is go ahead and square root both sides, or you can go ahead and just do, like, you can show it in a bunch of different ways. Like, you could actually show this like this, just to get a, or you could do like that. Really just depends on how you prefer to express this particular thing. And we're going to get a equals approximately 22 centimeters. So now we've solved for this. It's no longer an unknown variable. And remember, the units are pretty important. So we are able to solve for everything. You can actually go back and check this with your different ratios. Again, it's totally about how you approach these problems. These problems actually require a good amount of creativity. That's what it comes down to, is taking the steps that you need to take to solve it, but there always are different steps. It doesn't necessarily have to be the same answer on everybody's paper if they're applying their creativity. And sometimes, yes, there might be only one method or algorithm to solve it, but sometimes when you're solving a triangle like this, there are different ways to show your work. And as long as you understand the core values behind that, you'll understand everything. So if anyone has any questions about the stuff we did today, please feel free to let me know. We have about 7 minutes left, and I don't know whether or not we should get into another problem. You know, we can. I'm just trying to think whether we should or not, if there's enough time. You know what, actually, because we covered a lot today, I'm going to let you guys go a little bit early, like 5 minutes early. If you do have questions before we go, feel free to drop them in the chat and I'll spend the next 5 minutes answering them. But I don't want to get into a whole other problem because we won't have time to finish it, and I don't want to confuse anybody. So if this is stuff that you want to learn more about, come back next week. We're going to continue this because this unit is actually quite complicated. There's a lot more stuff that we need to know about it. And once we have gone through everything, then there are always opportunities for you guys to ask questions and get those answers that you might need. But in the meantime, I hope everyone is staying safe. I hope you're all healthy and well. And I wish you the best of luck on this week's distance learning. And if you have questions, feel free to send them in. Okay? Thank you guys. Have an awesome day, and we'll talk to you again soon. Bye.